In the year 2050, space travel has come a long way since the early days of space exploration. One of the most significant advancements in propulsion technology is the development of fusion engines. Fusion engines harness the power of the sun by using nuclear fusion to generate tremendous amounts of energy to propel spacecraft faster and farther than ever before. The process starts by heating and compressing hydrogen fuel by using magnetic fields until it reaches temperatures high enough to begin fusion. This in turn releases a massive amount of energy which is directed out of the engine as exhaust. Fusion reaction occurs when the hydrogen nuclei, or protons, are forced together, creating helium atoms and releasing a large amount of energy in the process. This energy is harnessed and used to generate thrust, which is used to propel the spacecraft. The specific impulse of a fusion engine is much higher than that of a traditional engine, meaning it can travel faster and use less fuel. To determine the time it takes to reach Titan, we need to calculate the specific impulse of the engine, the distance to Titan, and the mass of the spacecraft. The specific impulse is the change in momentum per unit of propellant. It is calculated by dividing the thrust generated by the engine by the propellant mass flow rate. This calculation gives us the efficiency of the engine. I believe the entirety of this trip could take approximately 16.5 months. Here is mathematical reasoning on how this is a feasible conclusion. Gravity assist is a technique that uses the gravity of a planet or a moon to alter the trajectory and speed of a spacecraft. By carefully timing the trajectory, the spacecraft can gain speed and reduce the amount of fuel needed for the journey. The spacecraft could use a gravity assist from Jupiter to increase its velocity, propelling it towards Saturn. After passing Saturn, the spacecraft will use a gravity assist from the planet and its fusion engine to decelerate and enter orbit around Titan. Once in orbit around Titan, the spacecraft would release a lander to land on the moon and explore. The manned lander would study the composition of the methane lakes and the hydrocarbon seas in search for other signs of life. The entire process would take approximately 10 months compared to the years it would take using conventional chemical rockets used in the past. This video has shown how fusion propulsion is the rocket propulsion technology of the future and how it could take a 35-man crew to Titan in not only under 3 years but 10 months. Thank you so much to AmCham and the Wood and Endeavour Scholarship for presenting this challenge to allow me to further my knowledge in the subject I love, which is astrophysics.